Well, my name is Michael Forey, and I'm a software engineer at Capital One. In my free time, I like to help high school students build electric vehicles. One of the key components of building and racing electric vehicles is building a vehicle that's reliable. I'm going to show you how to take the principles necessary in building an electric vehicle and apply it to your Tableau deployment on AWS.
Hi all, I am Anup Kunjuraman. I'm a senior software engineering manager at Capital One. And let me tell you, it's very difficult to do an introduction after Michael. The guy builds electric cars for fun. You know, telling that, okay, I build Hello World application and CRUD application for fun doesn't cut it after he takes out electric car out of the pocket, right? Okay, next time we are doing introduction, I'm going to go first. In Capital One, I deal mainly with analytical applications and data engineering side of things. I lead a few teams, mainly building data products. Except Tableau, everything is built in-house. The Tableau is only one of the only product where we take an external application and deploy it as it is in cloud. And we will go over that, over the journey that we did and how we achieved that all. A little bit about myself. I started my career building applications for mobile phones. Not the not the iPhone and Androids that you have. Think about a decade and a half back, where the Nokias and Sony Ericsson ruled the world. You know, where the memory of a phone was not measured in GB, but rather than, okay, you can now store 100 contacts on a phone, right? So from there, I went to develop software for set-top boxes, then pivoted to building, rather than building applications for set-top boxes, pivoted to understanding the data coming from millions and millions of set-top boxes. And then that landed me a job in Capital One, and I have been leading the data engineering teams there. Now, what's so special about Tableau and Capital One? I'm guessing you all know a little bit about Capital One, right? You all have seen the ad with Samuel Jackson asking the question, what's in your wallet, right? Most of you know Capital One as a credit card company, and rightfully so. We are one of the largest credit card issuers in US. What most folks don't know is that we are also big on a couple of other financial services, like we are the second largest auto financer in US. A little fun fact or a trivia that I like to add all the time is that we also own a Guinness World Record for contributing back to our community. We have a Guinness World Record for one of the largest artificial intelligence training that we provided to 800 plus kids from our Dallas ISD. We won that this year, actually. A little bit of fun fact that I try to plug in wherever I can. Now, Tableau and Capital One. What's so special? Most companies use Tableau as their analytical platform, right? Mainly the consumers of Tableau is going to be your leadership. They are trying to monitor the health of your business, about the health of your company. What happens if Tableau goes down for a few hours? What happens if Tableau goes down for a day? Not much, right? You can still survive. Your company is not going to burn down in that few hours. Not so sorry, I'm looking at the right slide. Okay, all right, sorry. Not so in case of Tableau. Not so that in case of Capital One. In Capital One, Tableau is used everywhere. Tableau is used by everyone. That basically means that if Tableau goes down for a few hours, the loss for us is going to be in millions. So it becomes our responsibility to make sure that we have a Tableau infrastructure that is highly available and resilient to failure, right? Now, our journey. Banking industry is a very old industry in US. The largest bank has its roots going back to 1700s. The second largest bank was originated in 1800s. Capital One, we recently celebrated our 25 years. Still, we are able to compete head-on-head with all those century-old behemoths. Why? Because of some carefully put-in strategies by our leadership, mainly our talent strategy, which is to attract the best from the Googles, the Amazons, the Netflix, the Facebooks of the world, and retain them and provide them an environment where they can deliver the best. The second was the digital transformation strategy, which was set forward around 2015, where we boldly said that, okay, all of our applications from this point onwards will be in public cloud in AWS. Everything new will be straight ahead deployed in AWS. Everything old and currently existing, we are going to re-engineer them and put it in AWS. I got the responsibility of the Tableau infrastructure about 2 years back. I was asked to keep the lights on 24/7. One of the first projects that was given to me was to move the infrastructure from on-prem to cloud. Here we are going to talk about what we learned in this journey. We are trying to distill all the learnings that we have, all the successes, all the success factors and the failure factors. Also some things that people won't tell you that you have to worry about when you actually need to go through this journey. So we are trying to put a spotlight on the success, failures, and things that you need to worry about when you do a deployment strategy in cloud for Tableau. Many things that we are going to talk about is actually applicable to applications outside of Tableau as well. Like we are going to talk about RTO, RPO, your deployment strategy, your disaster recovery strategy, things like that, which is common for many applications, but we are sort of tailoring and focusing mostly on Tableau in this journey. Now, this is our agenda for the day. We are going to start with a 5-point checklist. Now, think of this as equivalent to the 12-factor application that you probably know about. This is that 12-factor distilled down for Tableau. Then we are going to go over key drivers for success, also common mistakes that you are going to face in this journey. And at the end, we are going to go through monitoring and managing. They are not an afterthought. You need to worry about that the moment that you are trying to create a deployment strategy. So we are going to include that as well in our agenda.
Thank you, Anoop. When you develop your deployment plan for Tableau, you should meet these 5 criteria. You should have a change-controlled code base. So this includes having your infrastructure as code, having all of your binaries and executables stored in a change-controlled environment. You should have your infrastructure dependencies clearly laid out. You should have environment isolation and also environment parity. So your dev environment, your QA environment, your prod environment are physically isolated from each other, but they're also similar so that you can easily promote your deployment from one to the next to the next. You should employ disposable infrastructure everywhere. This includes having things that start up quickly, you can scale up and down, and when there's a failure that you can recover gracefully. And then last but not least, you should have a thoughtful design that's designed to meet your SLA requirements with your customers. If something goes down, we're going to be up by this amount of time, and we're going to lose X amount of data. And the design of your deployment should be designed to meet those commitments. The deployment that we have at Capital One gives us an edge over other deployment designs. If you go out on the open internet and you look for different ways to use this BI tool or that BI tool, or you want to use Tableau and you want to know the best way to get started and deploy, you're going to find 1,001 different solutions, right? Even major cloud providers that I won't mention have a particular solution. Tableau themselves have mechanisms on this is how you should deploy quickly and reliably. All of them that I've seen fall short in at least a couple different areas. What you're going to see with our deployment here is that we minimize manual interactions, right? There's a famous cloud provider where they'll say, hey, we can start up your Tableau server really quickly. And the first thing they do is give you a 30-point fill in the box on how do you want to deploy yours, right? If you're typing in your, we'll call them security groups, right? Your security groups each and every time you deploy, and you fat finger one little number, it all goes to pot, right? So as great as those types of solutions are, they're still lacking. Or even if you've got a way to just spin up Tableau, they don't include turning on your EC2s and attaching infrastructure and monitoring. What we have at Capital One is flexible to include blue-green deployment. It's well documented and consolidates information through version controlled. It's organized and structured. It's robust. And it's optimized to reduce manual interactions and also time to deploy. Before we had this deployment strategy, I estimate that we would deploy our server in about 1,000 button clicks, right? The way you should think about this is there's 1,000 opportunities to make mistakes. And we drove that down from 1,000 to less than 10 using this framework. And I'm going to show you specifically what we do. I see some pictures. I'll give you all a chance to finish taking pictures. Don't worry, there's more opportunities for good pictures later. All right, this is the actual infrastructure that we have at Capital One. In our region, we've got multiple Tableau servers, distinct servers. I call this out because sometimes I've been talking to people and they'll say, oh, I support LOB1 and they've got their Tableau server. LOB2, they want a different server. LOB3, they want a different server. How would I do that? Well, we handle that. You can have as many distinct Tableau servers as you actually need. In our specific situation, we have a production server here that's spread out across multiple availability zones. And then we have a staging node, just a single computer, that's also in that same region. Now, all of this infrastructure is replicated in our DR region. So you can think, all right, what if there is a hurricane on the eastern seaboard? What do you do? Well, we've got all the infrastructure necessary, all the EC2s, load balancers, files, everything on the other side of the country, and we can spin up very quickly. The traffic gets routed to different load balancers through Route 53. And the S3 buckets have cross-region replication. So whenever information is sent up to one S3 bucket, it's in the other S3 bucket shortly thereafter. So if you're thinking about, hey, how am I going to tell my customers that we can recover from an outage within X time period? What you want to do is say, all right, I'm going to set Tableau to set a backup, and then that backup is going to go to an S3 bucket, and then instantly that information is going to be in a completely different S3 bucket that's resilient to any outages that might appear. And the time of information that you have to lose is however often you've set Tableau to set those backups. We use CloudWatch to monitor key performance indicators on our infrastructure. That information is sent to our administrators. We're going to talk a little bit more about monitoring later, but one thing I want to call out is there's 1,001 different ways to monitor your infrastructure. You want to make sure that the thing that monitors your infrastructure is not actually your infrastructure itself, right? Tableau can monitor itself. That's very useful. We do that. But if Tableau goes down and you're using Tableau to tell you that it went down, it's never going to tell you that it went down. So make sure that you're using something else. Amazon CloudWatch is an excellent way to do this. This is a good time to take pictures, by the way.
And what you're seeing here is basically an active-passive deployment strategy. Only one region will be active at one time, and the other will be passive. And in case of a disaster, we have to manually bring up the other region. The reason why it's active-passive and not active-active is basically because Tableau has certain limitations in its current version to support active-active. If we have active-active, the Tableau will hit our database from both the regions, all the subscriptions, the email sending things, everything will be duplicated. So that's the reason why we have active, passive.
Thank you, Anup. This infrastructure is showing just our prod. I'm not going to show you QA or dev. It looks exactly like this, except that none of this stuff actually exists until we actually need it. So if we want to go and make changes, we jump into QA, we play around a little bit, we click a couple of buttons, everything that we need gets created right then and there. Then when we're done with it, we just throw it away. Let's talk a little bit about tactical examples, right? How we implement the five items on our checklist to have a successful deployment. AWS is a wonderful solution for combining with Tableau. They give you a myriad of features that help tie everything together. They've got a wide variety of EC2s. They've got multiple availability zones for high availability servers, golden AMIs, CloudWatch to monitor, CloudFormation to tie everything together. At the heart of what we do, we're using parameterized scripts. So one thing I'm going to keep harping on again and again is the reduction or even elimination of manual intervention, of people doing things. Some of you are thinking, oh, I'm a server admin and I got to justify my paycheck by doing work. Okay, I'm really sorry. Like, hopefully I will get you out of that and you will do less building and creating and more innovating, perhaps. So we have parameterized scripts, and at the very beginning, we use CloudFormation templates, where the user goes in and inputs a select number of parameters. The CFT creates the first node in your server, and then it'll create as many additional nodes as you set up. Now, additional nodes, like total node number, isn't a drop-down or an input. Your CFT will calculate how many nodes do I actually need based on the settings that you apply. Because AWS is the way it is, and Tableau is the way it is, you can have as many nodes as you want. I've heard of people doing dozens of nodes. Surely you can do 1,000. I've never seen anyone do it, but you could. All information is derived from an S3 bucket, and I'll jump into the S3 bucket more in a little bit. Anything that needs to be saved is saved in an S3 bucket. We use S3 buckets because they are reliable and robust. Information is passed back and forth between the nodes, both through the S3 bucket and directly once all the software is set up and installed on the nodes. The nodes will communicate among themselves as appropriate. And then the Tableau will also set up an automatic backup. Now, if you're familiar with AWS, you know that you can schedule snapshots. Those are fine and dandy. That's not the same as telling Tableau, hey, I want you to back everything up and save it on an S3 bucket. Last but certainly not least, your CloudFormation template will create CloudWatch and alarms and assign them to specific topics so that your administrators can get notified of important things. Oh, I saw some pictures. I'll give you a moment. Mm-hmm. Let's dive a little bit more into the CloudFormation template that you go into to create everything. Now, the name of the game here is that you minimize the number of manual steps, right? You don't want to have a CFT that has dozens and dozens of places where you type stuff in or you can drop down or make changes, because all of those options are an opportunity to make mistakes. So our CFT has 3 options. I'm going to show you a video in a second. There are more options than just these 3. The rest are just dummies. I haven't gotten around to deleting them in the video. So the user can choose the region that you want to deploy in, east, west, the type of deployment, whether it's production or test, and then optionally the host URL, right? What URL does Tableau expect to be receiving traffic from. Now, based on these three drop-downs, the CFT will calculate a handful of other variables. This is just a sample. And the reason why you want Tableau to calculate these is because, for instance, your S3 bucket that you pull information from, that's not going to change on a day-to-day basis, right? You don't need to type that in. You want to have that programmatically identified. You say, oh, I'm doing a production deployment. That means that I'm in this account, and I'm going to do it in the East. Therefore, my S3 bucket must be this, right? You don't have a wide variety of options, and you don't want the user to input a wide variety of things. We use S3 buckets to store all of our information. I've talked to people, and various people will say, oh, well, you pull scripts from an S3 bucket. Well, where I work, we manage all of our scripts on GitHub. Well, we do too, right? I don't pull from GitHub, though, right? And the reason is my Tableau server has certain SLAs. If something goes down, I promise my customers it's going to be up and running within 2 hours. GitHub's SLA is 12 hours. So if my server goes down and GitHub is in the middle of an upgrade that takes 12 hours, then my SLA just got shot, and there's nothing I can do about that, right? So if you guys want to rely on something other than an S3 bucket, go right ahead, right? There's a wide variety of places where you can store your data, but going back to having a thoughtfully designed deployment pattern, make sure that the things that you're relying on are more reliable than the thing that you're working on, right? Don't rely on something with a 12-hour SLA if you've got a 2-hour SLA, or even if you've got a 12-hour SLA, because they might go down at the same time that you go down, right? S3 buckets, highly reliable, highly available. We structure all of the data that we store in S3 for consistency. We have a folder. This is the actual folder setup that we use, right? We have a folder for all shell scripts. We have installation instructions, config files, topology files, node config files. We have a separate folder for drivers. For Tableau, you can connect to a wide variety of data sources, and you need different drivers. I do not go out to the open internet to say, oh, I need the such and such driver, give me the latest version. Because if somebody makes a change that you didn't test in QA, then your deployment could go south, right? I've got another a folder for binary executables, right? There is an executable for Tableau that you have to install on, right? I don't go to Tableau.com. I love Tableau.com. You get a lot of great information there, right? But I don't know what their SLA is. And if I've got a 2-hour SLA, and I need to install the right version of Tableau, and Tableau.com happens to go down, there's nothing I can do about that. So I go out to the open internet, I download the version of Tableau that I want, I test it in QA, right? I have it installed in an S3 bucket, and that's where I pull from QA. And then I install it in a separate S3 bucket for production and for dev. That's what I pull from when it comes time for me to install. I have another folder for CloudFormation template JSON files. Right? They've got to be stored somewhere. Put them here. Lastly, but not least, I've got a folder for backup files. Again, you got to store it somewhere. These are multi-gig files. S3 buckets are more than capable of holding very, very, very large files reliably, accessibly. This is a great place to put them. I've got one section for the latest, right? It's called, the latest. And every time I run a new backup, I overwrite that one, and I've got version control on that one. But I also upload a time-stamped version, so I got it in 2 different places. Maybe this one's corrupt. All right, I'll just roll back to the next one. Easy peasy. We run shell scripts on our EC2s. There are thousands of different configuration settings for Tableau. Tableau is a wonderful piece of software. It can be customized for a myriad of different scenarios, right? You can have it set up your way, and you can set it up different in your environment, and they could be completely different and hugely successful. And if you step into her environment and you say, okay, I'm going to deploy Tableau the way I know, but I'm going to make a couple of changes, it's very likely that you're going to make mistakes. So take whatever configuration settings that you want and put them in a shell script so that a computer installs and configures Tableau right down to every last process on each last node. The shell scripting should be kicked off by the CFT. Again, going back to our mantra of reducing human interaction, you want your CFT to not only kick off the shell scripting, but also to pass through any necessary parameters that you actually need to get it going, right? In my example, in my deployment, we pass through the S3 bucket because the shell script is about to download a bunch of files from a specific S3 bucket. Whether it's the initial node or the additional node, whether it's prod or test in the host URL. It dynamically calculates a handful of other parameters. All files are downloaded from the S3 bucket. Now, in your specific scenario, you might say, I want to pull shell scripts from a GitHub file. Okay, we talked about that. If you want to do it, hey, no big deal. Just tell your shell scripts, all right, this stuff comes from this S3 bucket, this stuff comes from Artifactory, this comes from GitHub, this comes from, right? Not that challenging. Anything that needs to be stored goes right back to the S3 bucket. Again, per my previous comments on S3 buckets, if there's a file that is near and dear to your heart that you don't want an S3 file, you can upload it to wherever you deem reliable and consistent. Now, many of you are looking at what I've talked about and you're thinking, so Michael, you're telling me that you want to have just a computer kick off and create all this infrastructure and install and have you ready to go for the production and then switch over and be the production thing without any human interaction? And I'm saying, yeah. And some of you you're getting kind of nervous and you're thinking, hold on. Like, you can't just click a button and have everything go to production. I need to test and check and make sure that everything is on the up and up, right? I've got to add value and step in the middle and make sure that everything is going A-okay. We've got regression tests for our models, or we got to do verification that nothing weird is going on, or okay, I got you covered. You can bifurcate your script. Your shell scripting runs in stage 1. It activates Tableau as a trial license. It disables subscriptions. It configures the cluster with a test URL. It restores from the latest Tableau backup, and then it stops, right? And you can just let your cluster, this new cluster, just sit there. Subscriptions are off, so nothing's being refreshed. No one's being emailed about something that failed or passed, right? You've got your own dedicated test host URL that you can pass off to your QA team or to an independent tester, or just keep it yourself, log in, do whatever tests that your heart deems necessary. And then once you are satisfied, you move on to stage 2. You activate Tableau with the full license, you turn on subscriptions, you switch over to the production URL, you restore the Tableau repository, and oh, by the way, all of this stage 2, this is not manual steps, this is just another shell script that does all of this, right? In an early version, when we were rolling this out, I was like, oh, stage 1, we'll script that. Stage 2, it's easy peasy. We'll just do all that stuff manually. Somebody made some mistake. Emails were getting sent to the wrong place. It was a mess, right? And I sat and I thought, hold on a second, I already solved this problem. I can just script all of this stuff, right? That's what you should do. Script it all, right? Minimize the number of human interactions. Amazon provides a wonderful, cohesive set of tools. Your CFT can kick off CloudWatch and SNS topics so that you can get alerted when something goes south on your infrastructure. We use CloudFormation templates and CloudWatch to create alerts on CPU usage, network utilization, EC2 status information, You can also have SNS topics alert of a wide variety of things, right? You can have it email Tableau admins. It can send text messages. It can even send information to third-party monitoring systems that we'll dive into later, right? Like Datadogs or PagerDuty. It's very flexible. All right, now let's dive a little bit deeper into the weeds. Now, I don't want to scare you off. We're going to get a little technical here, but don't worry. It's just for 2 slides. We want to talk about common mistakes that you should avoid. Right? We've talked about some of the great things that you can do and should do when you combine Tableau and AWS, but there's a couple of spots that you should look out for when you go to actually build everything and put it together. You want to make sure that in your shell scripting that you log into the TSM, the admin console, often, right? Tableau will automatically log you out after a certain period of time. I'm not really sure how long that is, so just tell your shell scripting to log in often. You want to log error codes so that you can diagnose things that go wrong. You want to watch out when you make changes to your CloudFormation template. They're very sensitive to formatting changes. So I know you're already making small changes and testing, change, test, change, test. You really can't move too fast when you make changes to CFDs. That's all this is saying. In your shell scripting, go ahead and install drivers last. If something goes wrong with installing a driver, it's pretty straightforward to log in, install that driver manually. You don't have to restart anything. If you install drivers up front and something breaks, well, then you just stopped everything else downstream. Throughout your code, you're going to have polling times. You're going to create a node that's going to then wait on another node to be up and ready, and you're going to have polling going on. Are you ready? Are you ready? Are you ready? Go ahead and make it poll for a really long time. I started off polling for 15 minutes, and I figured, okay, if it's not ready within 15 minutes, then something's broken. And I was right, and then I made a couple changes, and it wasn't ready after 15 minutes, but it was ready after 16, and my entire script broke. So now I poll for 10 hours. You want to be careful when you go through coordination service cleanup. I'm not going to dive into this because coordination service is a technical area within Tableau. Once you're ready to go and be a Tableau admin and you're jumping in, right, you're going to find out what this is and just be careful with the cleanup. I recommend that you apply settings in this order. Before I show you this list, I apologize. There's a lot of letters on this slide. I'm not going to read through them. If you want to take a picture, get your camera ready, and then, okay, go ahead, take a picture. There you go, there you go. Yeah, we're good. Okay, good. All right. Slide 2 on common mistakes. The last slide was about reducing errors. This is about reducing unnecessary time. So rule number 1 when deploying Tableau is you want to minimize the number of times that you have to restart Tableau. My whole deployment from end to end takes about 2 hours. If I were to throw in an extra turn off and turn back on again, that'll add 40 minutes to that whole deployment time, right? So you want to eliminate all opportunities that require you to restart, such as applying pending changes, granting access to the repository, restoring, adding or removing a node, change cluster controller, moving the file store. Go ahead and take a picture so that you can remember this, because there's no merit to this slide except for when you're in the weeds actually doing this. All right, so that's as technical as it's going to get, right? All right, so breathe a sigh of relief. Let's watch a video. Let me see if, oh, nope. Oh, there we go. What are we looking at? Okay, can I actually pause this? Nope, I can't. Okay, not pausing it, that's cool. So what we're walking through here is me actually deploying a cluster. This is the CFT screen you see at the top. I punched in the stack name. Down here, there's a variety of drop downs, right? I select environment variable. The install type, I want to install a full-on cluster. A couple other things in here that don't matter because I haven't gotten around to delete them. I go next. Oh no, I made a mistake. Not a big deal. I can't change the stack name. All right, now I go next. I'm not going to read that. Next. Down, 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 down. I acknowledge. Does anybody really read those things? Next. And that's it. That is me deploying a full-on cluster for Tableau, right? How long did that take? Less than a minute. How many buttons clicks? Does anybody count the button clicks? Anybody want to see it again to count the button clicks? It's not a lot, right? Compare this before. We're talking about full 8 hours of a human being doing active work, clicking a lot, down to about a minute. And I even threw in a mistake in there. I kept the mistake just to show, okay, you screw up the name of the thing, not a big deal, right? Total number of clicks, still about 10, less than a minute.
All right, now let's talk about monitoring. Now you followed Michael, you followed all his advices. You created a cluster, you gave it to your end users. Now what? Your end users are complaining that, okay, your server is down, right? That's bad. How do you make sure that you are the first person to know about the health of your cluster, and hopefully not from the users, but somehow, can you automate that? Can you make sure that we know about the health of the cluster much before our users even know that there is a problem, and remediate that if possible? Now, in the order of this slideshow, we put monitoring after deployment, but it's definitely not an afterthought. You need to worry about your monitoring strategy at the time that you create your deployment strategy. Michael went through the CloudWatch alarms during his deployment. You need to, if there is one thing that you want to take away from this slide, is that you need to have a monitoring strategy. In Capital One, this is what we use. This is a stack that we use. We use CloudWatch to monitor our infrastructure. We use Prometheus for both infra as well as app monitoring. We also use PagerDuty as our alerting mechanism. It doesn't matter if you chose some other tool, that's perfectly fine. The key takeaway is you need to have a monitoring strategy, and you need to worry about it at the time that you create the deployment strategy as well. Now, CloudWatch, I'm pretty sure you are all familiar with CloudWatch. We heavily use it for our CPU status checks and network load monitoring. Prometheus is something that we do have an enterprise deployment on Prometheus, so we do not really, it's not too painful for us to integrate Prometheus with our Tableau infrastructure. All my teams heavily use Prometheus, and it plays well even if you have a containerized based workload, ECS or EKS or anything like that. It plays well with that. It plays well with Tableau as well. We use some additional metrics out of Prometheus compared to what we get out of the box using CloudWatch. For example, memory consumption. I mean, it is possible using CloudWatch. You need to have custom triggers in place to get memory consumption, for example. In addition to that, Prometheus gives us some additional alerts. For example, it tells me if a hard disk is about to fill up in next 4 hours, it's able to predict that, okay, this is going to be a problem. I need to alert somebody that the disk is going to get full in the next 4 hours. So there are pretty cool alerts that are already built into Prometheus. The graphs, the charts that you are seeing is basically Kibana that we are using on top of this one. So you can use anything, Grafana or any graphing tool on top of Prometheus to actually visualize this. And finally, PagerDuty. PagerDuty is a thing that alerts us. I hope that you all have a team that is dedicated to monitor. It may be your own Tableau administration team or another L2 team or an SRE team. It doesn't matter what name you call. It's important that you have such a team. if you have read the Google's SRE book, it starts with saying that hope is not a strategy. So don't hope that things won't go wrong. Have a team in place who can actually jump in and fix it if things break, right? So in our case, the teams who are responsible to monitor our clusters, they are already onboarded to PagerDuty. We have a rotating call schedule. It's pretty intuitive to go into the interface and see who all are on call for this week or for this time. And it gives you a lot of peace of mind, because if the person who is on call doesn't respond to a pager event after X amount of time, it gets escalated to the next person, and so forth. It goes up the chain until somebody actually jumps in and really tries to fix it. So have a tool set, have something to monitor your infrastructure, have something to monitor your application. We are talking about Tableau in this case, and also have a team or a process in place to get those pages and jump in and fix that. Now let's talk a bit about alerts. What sort of things constitute an alert? Is everything coming from CloudWatch or Prometheus an alert? No, we don't think so. We don't consider like that. An alert that is coming to PagerDuty is something that you need a human to intervene and fix. Let's, for example, imagine that you have black box URL prob monitoring in place for your region. If you have a solution that will bring up an entirely new cluster in another region, automatically route traffic to that region when that alarm happens, you really do not need a human to jump in and solve anything for you. An alarm occurred, but it doesn't really need to be routed to PagerDuty. There is an automated process already in place to handle that. That doesn't constitute an alarm for us. An alarm is something that cannot be solved programmatically, that we haven't implemented an automation to solve it. That needs to escalate to a user. If you blindly send all alarms to PagerDuty, what will happen? All the alarms are going to be ignored, right? Because nobody is going to take that seriously. Only serious things should reach PagerDuty. Only serious things should cause a person's mobile or pager to ring. Second thing about managing Tableau well. Now, we created all this. We exposed the whole thing to our end users. What happens? Normally, a little bit of chaos. We have, so let's talk about backups, right? What happens when a cluster goes down? Do we lose all the data? We need to worry about how much data loss we can take, right? With every application, we need to worry about if that application goes down for X amount of time, what is the maximum amount of data that I can lose and I'll still be okay, right? That is defined by what is called RPO, or recovery point objective. For every application, you need to have a figure in mind. For us, in our Tableau world, we have configured that as 3 hours. Basically means that if Tableau went down, we are fine if we lose 3 hours of extract refresh data. That's fine. Our business will live with that. Because once Tableau is back up, we can rerun all those jobs. We are fine with that. 3 hours becomes our RPO, and that defines our backup frequency. That basically means that the script, the automated script that Michael was talking about that runs in all the EC2 instances, they make sure that they are running and backing up every 3 hours. Now, is that enough? We all have heard scary stories about people thinking that they have a backup in place, but when an actual disaster hits, and when they actually try to recover from that backup, they see that, okay, that they are all corrupted for the last few months. There is not even a good backup to use, right? How do you fix that problem? What we did in our side is that we have regular war games twice every month, where we actually are going to we created a playbook of what we need to do when a disaster hits. And we are going to play by that playbook one by one about what needs to be done. And that playbook is created so that even a newcomer who doesn't know anything about Tableau will be able to read through those lines and do those tasks and still bring up a brand new Tableau cluster up and running in no time. That's not a technical one. It includes even steps like, okay, at what point do you notify your end users that Tableau is done? At what frequency do you keep updating your users that, okay, we are still working on this Tableau, or all those email communication, the templates that you use for email communication, everything is part of that playbook. So even a newcomer to the team or even a completely different team sitting in your offshore will be able to play by that playbook and perform exactly as we think it's going to happen. We perform this war game twice every month. This is done by a team of 2 people, one to execute the steps in the playbook, and another what we call as a scribe who takes notes on what is happening. And once a war game is over, we go back, check the notes from the scribe, and see how we can make improvements to the whole process. And that gets added as addendums to our playbook and improvements to our playbook. So takeaway from this slide, having a backup is not enough. You need to make sure that you are practicing enough so that you can actually recover from stuff when things go bad. Now, so we have created an ecosystem of tools and APIs surrounding Tableau to support our enterprise needs. One of the things that we have built is a pipeline where any data regarding refreshes happening to workbooks, how many refreshes succeeded, how many failed, all those metadata about refreshes are sent to our streaming data platform, which is based on Kafka. So if folks are interested to know that, okay, is my refreshes happening well and good, they can actually listen to those Kafka topics to get real-time updates about how the reports are performing in production. As another step, we also have built many number of APIs other than this one. For instance, we have built an API that works within our Capital Enterprise API gateway to make sure that you are able to refresh workbooks programmatically, which is sort of like a wrapper surrounding the Tableau's its own API. We also have an SRE team that monitors all these, the performance, the metrics that we spoke about from the different monitoring tools. We monitor the workbook refresh rate, the time it's taking for each of these refreshes to execute, the health of our cluster as a whole. Now, one thing that we need to keep in mind is that failures don't happen dramatically on one day. It happens slowly. For example, if your reports are pointing to Snowflake, there's a slow degradation in performance of your refresh extract. Today, your reports are running fine in 1 minute. Slowly, they take more and more and more time, but it's not enough to get into your radar. But at the end of 1 month, if you take a look back, 1 minute has increased to 10 minutes. So it's not going to trigger any alarms on your side unless you have specifically coded for that. So we need to have someone who periodically monitors all these matrices to make sure that everything is healthy. And this is on governing Tableau. It's highly Tableau specific. One is the way that we make sure that the production clusters are happy and healthy is that we do not let publishers publish anything directly to production. It makes sense. If you're coming from a software engineering background, we do not put things directly into prod. We take things into QA, staging, and then prod, right? At least you will have a build pipeline like that. Why not do something similar for Tableau? Many other companies, they use the same Tableau cluster. I have seen this in other places where they use the same Tableau cluster, the same infrastructure, but they dedicate separate sites within that infrastructure. One, they will call it as prod, and one, they'll call it as staging or testing or whatever, right? That doesn't help us. One of the main things that we are trying to avoid here is that a person who is new to Tableau, who created a not so optimized workbook, deploying something that takes too many resources into our prod infrastructure. If we combine prod and testing into one infra, you are not safeguarding against something like that. So we decided that we'll have 2 separate production clusters. One we are going to call it as prod, the other as staging. All of our report viewers or interactors will not have access to staging. Only the publishers of reports will have access to staging. They first need to publish their reports to staging, satisfy all of our SLAs before things can be moved over to production. Now, another pain point that we solved recently is about people, what happens when publishers leave Capital One, right? We have an automated system that provides access and takes away access. However, if you are publisher of a particular report, it will not let you remove a person from our Tableau system if that person owns a particular report. So we build additional tooling surrounding this, where if person X leaves, we change the reports that belongs to person X and move it to person X's manager, and then we'll have to manually remove person X from Tableau. So we build all these additional toolings to satisfy our enterprise needs on that. Another major pain point, people create Tableau reports and then leave it there even when they have stopped using those reports. Those reports still periodically, they'll have schedules to refresh, right? They'll still be utilizing all of our resources, but nobody's actually using that. So how do you fix that? So we build tooling surrounding that to actually monitor the usage of each of these reports, know how many reports are being actively consumed, and then take action accordingly. If the reports are not being used, they move automatically to an archive site, be there for X amount of time, and then get automatically purged after that time. Basically, we are giving users a screen window to let us know that, okay, they really, even if nobody is actually using that, they still need that report in there. But it gets purged after that X amount of time. We also have built systems where we can actually monitor the desktop license usage and remove people from the desktop license usage if they are not actively using that.
Thank you, Anup. So we've shown you how to deploy, how we actually deploy, but the fun doesn't stop here. Over the next year or so, we have in our pipeline a handful of other fun, exciting projects. Maybe we'll have the opportunity to come back and tell you about them. One thing that we want to do is do a triggered build of our DR region. Right now, if we want to build something up in our disaster recovery region, we showed you. You go to CFT, you click some buttons. We want to work on setting up a triggered. So when something goes wrong in our production environment, CloudWatch automatically finds out about it because we already have CloudWatch alarms. And CloudWatch sends something to a CFT in our DR region, and it automatically builds. We want to work on having dynamic Tableau topology. With Tableau, you can have X number of processes running to run SQL or to show pretty pictures, and the load that we need varies over time. We want to have these processes change as the demands ebb and flow throughout the day and the week. We want to do programmatic data source creation, so maybe work with AWS Glue to say, oh, we've got a new S3 file, let's go ahead and create something in Tableau. And there's some enhancements that we want to do on emailing and notifying people when things go wrong. That concludes our discussion. I appreciate you all for coming. And last but kind of least, AWS would like you to complete the session survey. I would like you to write your opinions on the back of a $20 bill. I'll let you choose which one you want to do. And Anup and I will be available for questions after this. Thank you.
Thank you.